Here is the assembly and detail set of drawings that we're going to do for this table assignment. This is a kind of clunky, heavy-duty table like you might find out in a shop for pounding on. And we're going to figure out how much this thing weighs, and we're going to find out it's pretty heavy. So later on, I think in a couple of weeks, we're going to do a revision to this table, and instead of welding the tabletop down, we'll make the tabletop bolted on so that a person could unbolt the tabletop and carry it separately, which will reduce the weight, or they could replace the top. Here are the materials in the table. I have already drawn the table for you, and in a minute we'll go look at the drawing and other stuff. Here are some notes about what the parts are made of. You will have 2 sheets to this drawing, or more. You could have more sheets if you want. The first sheet will be the assembly sheet, and it will have the assembly views and some dimensions. We'll put weld symbols on it starting next time. You'll have item number bubbles, you'll have a bill of material, and in a note you'll write how much it weighs. Notice this says sheet 1 of 2. Then on sheet 2 of 2, you'll have the dimensioned details of each part, showing somebody how to cut them. No bill of material on this sheet. So here is roughly what your thing will look like. Here's the assembly sheet, which will have weld symbols and item number bubbles and dimensions and the weight. And the bill of material. Here's the detail sheet, which will have dimensioned parts on it. When you dimension these parts, by the way, do not dimension any of the sizes that are as purchased that you already get from the parts house. So for example, here's an angle iron. I think it's 2.5 by 2.5. Well, that's just the size it is. Don't put the dimension on here. If you do, somebody will think, oh, I'm supposed to machine that so it's exactly the right size. So no, you just call out the angle on the bill of material, and then you dimension the length and the angles at which it's cut. On your assembly sheet, you will have an item number bubble on each part. Those bubbles need to be big enough to hold the 1/8 inch text, so around 3/8 to 1/2 inch diameter. And that item number bubble matches the item number in the bill of material. Then you need to figure out how many of each part. What's the quantity? So for example, looking at the bottom view of the table, see that long angle iron? There are 2 of those. The short angle iron, there are 2 of those. The cross braces, 2 of those. Those tubes that make up the legs, there are 4 of those. The tabletop, just 1 of those. You will look up the part numbers for these pieces of steel and put those in your bill of material. I'm going to show you where to find this. So just a reminder from fall term, when we had mechanical design class, this is our pretend company part list. Every company has their own part number system. This is ours. It's made up. This is the one we're using in our quote company. And you find the part number for the piece of steel you're talking about in this list, and you copy it into the bill of material in the part number field. Then you copy the description. You can use copy paste here. Copy the description and paste it into the description field in the bill of material. And then over here under size and reference information, not every company uses this kind of thing. We are using this in our pretend company. So it's helpful for the sawyer and the shear operator and the fabricator. You enter the size of the piece of material you're talking about. So for example, if you're listing the plate, the 3/8 plate that is the tabletop, over here you could write 48 by 36. If you're listing the tube that makes up the legs, over here you could just write the length of the tube. So that makes it easy for them to cut. And then the assignment says to calculate the weight. So how the heck do you do that? Well, the Far West Steel catalog lists the weights per foot of each kind of material that they sell, so you could look there. I have put those weights into our class parts list here, so you could just get the weights here, which would be easier. So for example, looking at the 2.5 by 2.5 by 1/4 inch angle iron, there's its part number, there's its description. It says the unit of measure, UOM is unit of measure. The unit of measure is linear feet, okay, and the weight is 4.10 pounds per linear foot. So if you have 1 foot of this angle iron, it will weigh 4.10. If you have 2 feet of that angle iron, it will weigh 8.20, and so forth. So make yourself a list on some scratch paper, or even in an Excel spreadsheet if you want. Make a list of all the parts of steel that you have, and remember to note how many pieces of steel and how long each one is, and then just figure out how much this total thing will weigh. Why do you care? Well, there are several reasons to know about the weight. One, if you were having to do something for a crane lift, this is a small table, but let's say you were trying to figure out how big a crane or maybe how big a forklift do you need to move this thing? Can you use your little tiny forklift, or is this thing too heavy? Do you need your big forklift? Or if this table is going to be part of some larger assembly, you might be calculating the center of gravity of the whole thing so that you could figure out where to put lifting ears or that sort of thing. You would need to know the weight for that. And there are other reasons, like if you're shipping, your customer is overseas and you need to ship it, you need to know how much it weighs. So let's go look at where to find some things for this assignment. Here is a handout that I have given you. It's a PDF, and here is sheet 1 in the PDF. Now I have already drawn, let me show you the CAD drawing. Here's the CAD drawing that you will download. I took pity on you and I drew the table, so you don't need to actually do the table layout. You just need to finish the other stuff. The bill of material is not finished. You don't have any item number bubbles. You don't have any weld symbols. We'll learn about those next time. You need to draw and dimension some details. So here is some information about that on this PDF with a note about what all you need. Needs all that stuff. And then here's an example from the detail sheet. This will be sheet 2 of 2, where you will dimension each of these pieces. Now, where do we get our Far West Steel catalog and our part number spreadsheet? In our course in Moodle, up here in the general course information, here is our part number spreadsheet. That's that list of part numbers we were looking at. So you can download that here. And here is the Far West Steel catalog. You might want to have a copy of this even if you're not using it right now. So let me see. I think that's all you need, but let me know if you... Oh yeah, let me talk about getting the part number details. So here's my assembly drawing of the table. And let's say I want to draw a detail of this long piece of angle iron. Well, because I have already drawn an assembly here, I can just make a copy of these pieces right here. And I can copy that over to somewhere. There. Looky there. There is my piece of angle iron, and I don't have to trust myself to catch the right dimensions. That is an exact copy of my piece of angle iron. So now I can go to my my second sheet, my B sheet, and let's see, what scale are we doing? I think we're doing a scale of 1 to 8 here. So 1 to 8 is not listed. Oh yeah, it is. Good. There's 1 to 8. So now I can have my piece of angle iron there, and now I can go back and put dimensions on it. All right. That should get you started. Let me know if you have questions, or be sure to post questions in this course forum too, so we can all talk about it.